Okay, so we're still in Geometry B, Unit 1, Lesson 2, on properties of parallelograms, actually. But I wanted to do a proof. So let's do a proof, because proofs tend to be the sticky wicket, the thing that give the most people trouble. All right. So we're going to prove something is a parallelogram. That's one of the common proofs that you're going to have. So let's say we've got some quadrilateral. Okay, and I'm going to sketch a quadrilateral over here that looks like a parallelogram, but we're not told it's a parallelogram. So we cannot use, if we're not told it's a parallelogram, we cannot use the parallelogram properties in our proof. Okay, so be aware of that. You cannot use parallelogram properties if you do not first know that you have a parallelogram. We've got some quadrilateral, right? And we're told some things about it, and we're going to prove based on those things that it is a parallelogram. Okay? And I'm going to do, let's see, decide how I want to do this here. Let's say the thinking of how I want to set this up. Going to pause the video for a moment. All right, I've got it. So I'm going to draw one diagonal of the parallelogram here. One diagonal. Here we go. I'm going to label the vertices A, B, C, and D. Okay, and we're going to be told some facts about this. We're going to be told that that AD is parallel to BC. Okay, AD is parallel to BC, and we're going to be told angle C is congruent to angle A. All right. Angle DCA is congruent to angle BCA. All right. So that ought to do it here. So here's where we're going to go with the proof here. So we're trying to prove this is a parallelogram. Prove this is a parallelogram. So we're given, and I'm just going to say given, and I'm going to state the facts that AD is parallel, segment AD is parallel to segment BC, and we're given that angle BAC is congruent to angle DCA. And what do we want to prove? We want to prove that ABCD is a parallelogram, and that's the symbol for parallelogram. Okay. All right, so now we're going to have our statements on the left and our reasons on the right. Okay, and we start with what we're given. So statement number 1 could say AD is parallel to BC. Okay, and the reason we know that they're parallel is that was given. Statement number 2 could say that angle BAC is congruent to angle DCA. And statement number 2 could say the reason number 2 is also given. And then we want to end with ABCD as a parallelogram. And I don't know the number of the step, but ABCD is a parallelogram. And we're going to use one of the 5 rules to prove that. All right, so here we go. Let's see what we know here. Okay, well, here's something I'm going to use. I'm going to use this fact here that AC is a side in both triangles, right? So statement number 3 is going to say AC is congruent to AC, or CA, right? AC is congruent to AC. And so therefore and there's lots of ways to do this here, but I'm going to go with that here. AC is congruent to AC. I just realized there's a simpler way to do this, but I'm going to go with this. Statement 3, reason 3 is called the reflexive property. Reflexive property of congruence. Anything's congruent to itself. All right? And statement 4 is going to say that angle DAC has got to be congruent to angle BCA. Angle DAC has got to be congruent to angle DAC to BCA, angle BCA. And the reason is these are parallels crossed by a transversal. And since they're parallels crossed by a transversal, alternate interior angles are congruent, and these are alternate interior angles. They're inside, and they're on opposite sides of the transversal. Okay? So alternate interior angle theorem, and that's the converse of the alternate interior angle theorem, which says if alternate interior angles are congruent, then the lines must be parallel. So 4, the converse of the alternate interior angle theorem. Okay? All right, and so guess what we've got? We've got an angle congruent to an angle. We've got a side congruent to a side. We've got an angle congruent to an angle. Okay? Therefore, step 5, triangle ADC, and make sure you line these up correctly, is congruent to triangle ADC. ADC is congruent to CBA. CBA. Okay? Congruent to triangle CBA. And how do we know? Reason number 5 is angle side angle. Okay? And now there's a lot of ways I could go here from this point, but I'm going to use this. I'm going to use step 6. Therefore, since the triangles are congruent, so are their parts. That is, AB is congruent to DC or CD. And so AB is congruent to DC. And AD is congruent to BC. AD is congruent to BC. How do I know? Because if two triangles are congruent, so are all their parts. Corresponding parts of congruent triangles are congruent. And now I'm ready for step 7. How do I know now that the shape is a parallelogram? By the rule that says if quadrilateral has opposite sides congruent, then it's a parallelogram. So if opposite sides are congruent, then it's a parallelogram. Okay, there we go. So that's an example of a proof that you might do in this unit.